Here we go, mathletes. So today we're going to talk about inverse functions. Inverse functions are where we swap the domain and the range of a function. And so we may start out with a function like this here, f of x equals x plus 4, and we end up swapping the domain and range, and we end up with an inverse function. An inverse function, we use this notation where it's f with a superscript -1 there. Of x, and so the inverse function of x plus 4 would be x minus 4, and we're going to look at that here in a minute. But basically that's what happens is the domain and the range swap, and again we use this notation. F inverse of x is kind of that -1 superscript there, so it's not an exponent. It doesn't mean 1 over, like if we have x to the -1 power, that means 1 over x. That's not the case with function notation, okay? And so this f inverse, when you use it with function notation, means that it's the inverse function where we're swapping the domain and range rather than any kind of exponential or power, okay? All right, now let's look at this function, f of x equals x plus 4, right? So we have this function here, and let's just find some input-output values for a second. So let's say, let's make a table here, and let's get some x and f of x values here. So if we input, let's start with 0. So if we input 0, we get 0. We put in 0 here for x, right? And we get 0 plus 4, which is 4. If we put in 1, we get 1 plus 4, which is 5. If we put in 2, we get 2 plus 4, which is 6. If we put in 3, we get 7, right? Put in 4, we get 8, and so forth and so on, right? So those are our input and output values, right? Input on the left, output on the right. And we can turn those into ordered pairs, right? 0, 4. All right, so these are the sets of ordered pairs, right? If we convert this into ordered pairs, we can do it that way, right? And we can plot those and on a graph and all the things. And so what we're going to do now is we're going to find a function where we swap the domain and the range, okay? So instead of these inputs for all these pairs, right, instead of these values being the inputs, they're going to become the outputs. And instead of these values that are the outputs, they're going to become the inputs, okay? And so that would be a function where we would have 4, 0, right? And so forth and so on, 5, 1. All right, and so the inverse function would look like this, where all of your inputs would change outputs, and all of your outputs would change the inputs for those corresponding values, right? And this is what the output function table would look like here, is if you put in the output from before that gave you, or that you got from this input, then you would get that input out, right? So it kind of reverses the function, right? Or it inverses the function, okay? And it undoes what the function did before, okay? So this function added 4 to everything and came out with this output, right? So now we're going to do the opposite of adding 4, which is subtracting 4, right? And that's going to undo what the original function just did, right? And so if we think about what that inverse function would be, this one's fairly intuitive. If we think about what can we do to undo adding 4, we would subtract 4, right? So the inverse function is going to take x and it's going to subtract 4. And that's what the inverse function for f of x in this case looks like. So this is the way you write it, f inverse of x, and then that's the actual function itself, which is x minus 4. All right, so we have these two inverse functions, right? These two functions which are inverses of one another. And one thing that's true about inverse functions is if you compose them, if you put one function into the other function into its inverse, or an inverse into its function, then something interesting happens. And so let's try that with both of these situations. So what we're going to do is we're going to start with f of x, and we're going to put f inverse of x into it, right? So in this case, I'm going to put f inverse of x into f of x. So I'm going to write the f of x function, x plus 4, but instead of writing x, I'm going to put parentheses, and in those parentheses, I'm going to put the input function, right? Which in this case is the inverse. So I put x minus 4 in there, and you can see what's going to happen is x minus 4 plus 4, since there's nothing out front or no operation, no exponent or anything like that, I can just ignore those parentheses. Negative 4 plus 4 turns into 0, and all we have left is x, right? So that's what happens in this case when we compose f of f inverse of x, right? We just get x. So let's try it the other way around. Let's say we take our f inverse function and we put f of x into it, okay? So this time I'm going to start with x minus 4. So I'm going to write out x minus 4, but I'm just going to leave parentheses where the x is. And now my input is f of x, so I'm going to put x plus 4 in there for x. And you can see when we combine these again, we don't need those parentheses. And these 4's will again cancel out, and all we'll have left is x in this case as well, right? So in this is a pretty simple case in terms of these two functions. You know, there's a lot of different function types and things like that, and when we find inverses, they'll have some more complexity to them. But every time you compose a function and its inverse, if they're truly inverses of one another, then you'll end up with x in those situations. Okay, so that's one way to check if a function is an inverse of another function, is you can input them into one another and see if it comes out to x.